So we have an 80-year-old woman with history of recurrent UTIs who presents to the ED with acute fevers and dysuria. She is febrile on exam, and she's also tachy to the 1-teens. Her blood pressure is in the 1-teens as well, systolics. On exam, she's raguring, she has suprapubic tenderness. Her UA shows pyuria and bacteriuria. And then in the ED, she gets ceftriaxone and she's admitted to your GMED team. So the next day, micro pages you that her blood cultures are growing gram-negative rods. You wait for the biofire, which comes back detecting E. coli, as well as the resistance gene CTXM. And all of her prior urine cultures have also grown E. coli, sensitive to cephalosporins, piptazo, and carbapenems. So the question is, how should her antibiotics be managed? Should we continue with ceftriaxone, switch to cefepime, switch to ertapenem, or switch to piptazo? So the answer here is we should switch to ertapenem. Let's go over why. So today's fast facts, we're dealing with gram-negative rods today, specifically our Enterobacterales group, and the two pathogens of interest are E. coli and Club pneumo. And these bacteria love to cause UTIs, intra-abdominal infections, as well as bacteremia. And we will often start ceftriaxone as empiric therapy to treat these infections, but the problem is E. coli and Club pneumo can sometimes become resistant to ceftriaxone by making these enzymes called ESBL. And before 2010, you would sometimes see on your culture results, they would explicitly tell you sometimes that this is an ESBL producer. And this is based on the microlab performing specialized testing with antibiotic discs on plates and then looking for specific growth patterns. But nowadays, very few labs will do this specialized testing unless it's for a big research study. And so instead, we look at whether the bug is resistant to ceftriaxone. And then if it is, we consider this to be a pretty good surrogate marker to tell us that this bug makes ESBL. And then for blood cultures, so in the past, once you would find out about a positive blood culture result and start empiric antibiotics, you usually have to wait an extra 1 to 2 days to find out what specific organism is growing and then what antibiotics it's actually sensitive to. But we now have powerful rapid diagnostic tools, one example being BioFire. And these PCR-based tests can be run as soon as growth is detected. And then 1 hour later, you can get info about the specific bug and then presence of any common resistance genes, including one for ESBL. And this quick 1 hour turnaround time can greatly speed up appropriate de-escalation or broadening of antibiotics. Taking a step back, ESBLs in general, they can be caused by many different mutations, I think over 200 of them. But the BioFire assay, which is available at our VA here, detects only CTXM, but that happens to be the most prevalent one in North America and most of the world too at this point. This also means, though, that the absence of CTXM on BioFire does not necessarily rule out an ESBL organism. And so for treatment, when you suspect bacteremia by an ESBL organism, you should use a carbapenem. In general, even if the later susceptibilities from your blood cultures say that it's sensitive to cefepime or piptazo, you should still avoid their use in bacteremia. And this is because there have been numerous studies showing poor outcomes in treatment of ESBL bacteremia when either of these agents down here were compared to carbapenems. So in summary, resistance to ceftriaxone for E. coli and Club pneumo is a good surrogate marker for presence of ESBL. Rapid diagnostic testing like BioFire can look for the CTXM gene, which is a good rule-in test for ESBL, but remember that its absence does not perfectly rule out this resistance mechanism. And then for empiric treatment, go for the carbapenems instead of these other agents down here because of increased risk of treatment failure.